Our project is to introduce and develop an autonomous security robot that can effectively respond and handle routine or emergency situations. So the SecurePath AGV rover covers the following functionalities, which include security surveillance and monitoring, medical or security emergency response, and also enhanced customer and staff interaction. Let's talk about our methodology for our project. Our methodology for our project includes the following, which is the SLAM navigation, danger detection, user-friendly chatbot, and also the automatic medical dispensing system. So, hello everyone, my name is Gochuk Fan, and I would like to talk about my part on SLAM navigation. Now, the design process of the SLAM navigation revolves around the nav2 package, which is used for navigation application in ROS2. The nav2 stack revolves around the behavior tree navigation server, which consists of the recovery, controller, and also the planner server. This server relies heavily on real-time sensor data, which in this case we'll be using a LiDAR sensor and also wheel odometry. By using a looping algorithm, the waypoint follower node constantly provides a target post to the navigation server, and this navigator server in turns will provide a velocity command to our actuators, which is connected to a motor driver. In this case, we are able to produce a final result which consists of autonomous patrolling capabilities combined with obstacle avoidance. However, there are still some flaws in our current navigation structure, which can be further enhanced by integrating multiple sensors. In this case, we are talking about an inertial measurement unit, or also known as a IMU sensor, to prevent wheel drifts. And we can also include a bump sensor, which is used to detect obstacles which are out of the sensor range of the LiDAR sensor. With the integration of these multiple sensors, we are able to provide a more accurate localization and navigation uh, structure, which results in an enhanced autonomous navigation capability. So that's all for my part on the SLAM navigation. Thank you.
Of the danger detection. So the two models that I have used in this detection is the face recognition, obviously, is for face detection and recognition. The second one is the media pipe, which is useful in waving and fall detection. So how does it work? For face recognition, each faces that is detected in the image that is captured from the camera will be saved. The feature of each faces will be extracted by converting it to a numerical value, which we call it as encoding, using the pre-trained deep learning model, which is a deep face and delete in this case. Whenever a face is detected, the face encoding will be compared. With these features, we can easily find the matched faces that we wanted to find. Next is the waving detection. So this media pipe will extract the hand landmarks. So whenever our hand is widely open towards the camera, and the position of our hand in the previous frame and the current frame is different, it indicates that the waving is detected. So it will trigger a chatbot so that the user can communicate with the chatbot. While for fall detection, we have these body landmarks to be extracted, and whenever the angle between the torso and the leg is more than 45 degrees, it indicates that the person has fall and attention needed for that person. Let me show you some result of my detection. First is the waving. So as you can see here, the user will only need to wave to the camera and the welcome page will be turned off. The chatbot will be activated soon. Next is the face recognize. This chatbot has the function of face recognition. With the save image command is triggered, the program will save the first face that is detected into the database. So after this chatbot has shut down, the robot will be continue with its normal detection. So whenever the face detected from the camera is same as the face that is saved in the database, it will show the message of match found. Last but not least is the fall detection. As you can see here, whenever the person has fall, the program can accurately and immediately detect it. The three detection that I have mentioned are serve as a basic detection of the danger detections. So What I am going to do for the further enhancement is that I will integrate all the detections and apply with reward functions. By doing this, detection and prediction on danger can be more accurate and it will enhance the security level of the retail environments. And that's all from me. Thank you.
Now I'm going to discuss about my past, which is the user-friendly chatbot. So in this design process chatbot, the diagram explains how a chatbot system operates using the Llama 2 model, which is a powerful AI model developed by the Meta AI by outlining the flow of interaction between the user and GUI and the AI model. So the user interact with the chatbot by providing the prompts, for example, the question, command, or statement through a graphic user interface, which is the short form GUI. The GUI is designed to be a user-friendly, ensuring intuitive and seamless experience for entering and viewing the interactions. So the chatbot GUI connect to the Llama 2 model through an API token. This API token is obtained from the Hugging Face, which is a popular platform for hosting and access the AI model securely. So the token ensure the secure and authentical access to enable the GUI send the user prompt to the Llama 2 model for processing. Once the user input is received, the Llama 2 model processes the data, leveraging its advanced natural language understanding capability. The model generates a content-aware and a meaningful response based on the input. The generated response from the Llama 2 model will be sent back to the chatbot GUI, and then the GUI will display the response in a clearly and user-friendly format to ensure the user can easily read and interact with it. The system enables the smooth and continuous bi-directional communication between the user and the AIs. Prompt and response flow efficiently create a conversational experience that feels natural and contextual aware. So in this diagram, for the final result, the diagram illustrates the key component of the final LLM chatbot product, which integrates multiple functional to create a comprehensive AI-driven assistance. The chatbot initialization module focus on preparing the system for user interactions, ensuring the LLM model and essential tools are loaded seamlessly. So the response generation model process user inputs, enabling the chatbot to generate the intelligent, context-aware replies. The communication function extends the chatbot capability by enabling it to interact with the external device, such as RealSense camera and the Arduino microcontroller. This function empowers the chatbot to perform a real-world action, such as detecting objects, triggering the specific operations, or initiating the workflow based on the user command and integrate device feedbacks. So together with combining these all components, it will create a dynamic and versatile chatbot system suitable for a wide range of applications. So for the further enhancement of this LM chatbot, this involves improving the chatbot ability to process the audio inputs, particularly when the user interacts through the speech. The enhancement including handling challenges such as distinguish between multiple speakers, ignoring the background noise, and accurately converting the speech into text. This step ensuring the better precision in understanding spoken commands, especially in the real-time or complex environment, for example, in the retail environment or some emergency situations. By integrating the text-to-speech functional, the chatbot can deliver the response in the natural, more human-like voice. This feature is particularly useful for accessibility purpose or scenario where the user prefer auditory feedback instead of reading text. It also improves the interactive, making the chatbot feel more conversational and user-friendly. So upgrading the chatbot interface focus on making it visually appealing, intuitive, and easy to navigate. So this might involve improving the layout, adding some interactive visual, and ensuring the design align with the user needs. A user-friendly GUI enhance engagement and reduce friction when the user interact with the chatbot to improve the overall user experience.
automatic medical dispensing system. Actually, what's it? It is actually an efficient system which able to dispense the item in a few seconds, which to solve the problem of low efficient way to direct get the medical kits in the real life. So without further ado, let's see how does it work. You might wonder, how does this system works, right? It actually is a system that is highly relied on the real-time communications and the close connection between the LLMs and the system. In a in the emergency situations, there is a medical kit is needed. The system will automatically dispense the required items by the cooperating between the PCA 9685 module and the SG90 servo motor. These items are collected inside the baskets. Once all necessary items are ready to collected, the system will activate the automatic drawer, and this drawer will work using the rack and pinions mechanisms powered by a high torque servo motor MG995. The dispense the dispenser itself it consists of 9 compartments, each stocked with the different emergency suppliers. For example, like adhesive bandage, iodine, plaster, and so on. Okay, here is a 1-minute demo videos that will show how does the system work. This the middle one is the LM chatbot that made by teammate Chong Chanting.
I accidentally cut myself.
Okay, he asks what if he being cut itself, what will be the react of the LM chat.
Do you have any iodine?
Now he requests for the iodine.
Yes, please. Yes.
As you can see, automatic drawer will be. But now
Do you have any adhesive bandage? Do you have any adhesive bandage? Yes, I need it.